I missed all 2 points on each one.
Okay, so law of cosines. I didn't leave a blank for you guys to write it, and there aren't 3 of them. There is 1, okay? So when we look at a triangle and information given to us about the triangle, we say, can we use law of sines? It's quick, it's easy to do, yes? So we would use law of sines. If we cannot do law of sines, so when couldn't we do law of sines? What has to happen for law?
We don't have an angle.
When we don't have an angle, so we don't have any angles, we can't use law of sines, or we don't have a pair, right?
Yeah.
Okay, so when we can't use law of sines, you use law of cosines. That's it. Okay, we're just going to look at the 1. What does this remind you of?
A squared plus B squared equals C squared.
Yeah,
Rearrange.
it comes from the Pythagorean theorem. That's where it comes from. And what you have here, we're just going to look at relationships, okay? So I have side A squared equals side B squared plus side C squared minus 2 BC cosine of A. Guys, it's called law of cosines, so what function are you going to use? Cosine. Just putting that out there because you know how many times people use law of sine? Or they put a sign there.
I'll probably use it.
Okay, just for me. So let's look at the relationship here. So if I'm looking for this side, the angle I'm using is that angle, yes? Okay. And so then the other ones are just the other 2 sides, correct?
Yeah.
So it's side squared equals the other side squared plus the other side squared minus 2 other side cosine of my angle. That's all it is. So when I do B, it should be A squared plus C squared minus 2AC cosine of B, right? Right?
Yeah.
When I do C, it should be AB 2AB cosine C. So are there really 3 equations? No. It's really just 1. So let's look about it here. So this would mean I would have this one. Oh wait, I'd be looking for this, right? So let me erase that. So I'm looking for this. This is my question mark. And I have this, and I have this. So it's basically 2 sides and the included angle, right? Isn't that what you need for the first area formula? 2 sides and the included angle. So if we can't use law of sines, that's when we use law of cosines. Everyone always says, when do you use what? That's when. Got it? Do you know when you can use law of sines? Alex, stay off your phone.
Opposite angles.
When you have a side angle, right? When you have a side angle ratio, you can use law of sines. It's quick. It's easy to use it. Yes? This isn't overly difficult. It's just a lot more parts. Okay, so we're going to come down here. It says number 9, example number 9. Solve the angle, and we're gonna find the area too, because that's what you're gonna do on your assignment. You're gonna solve the triangle and find the area. More practice with area. It's pretty easy, right? So the first thing I do is make a what? Triangle. Oh, forgot to tell you. No ambiguous cases. You know why? Because ambiguous cases came because sine was positive in both the first and second quadrant, correct? Well, we are, but cosine, what's cosine in the second quadrant? Negative. So it's either in the first quadrant or in the second quadrant. It can't be both. So there's no second triangle to check for. Awesome, right? The other thing is when you start with law of cosines, you need to finish using law of cosines. Am I clear? The reason for that is if you go from law of cosines and then jump to law of sines, first of all, you're using something you found, right? And sometimes we have to, but then you might have to check for an ambiguous case. Do you want to have to do that? No, it's just as easy just to stick with law of cosines to finish the triangle. Does that make sense? So when you start with law of cosines, you finish with what? Law of cosines. If start with law of sines, I finish with what? Law of sines. But I don't ever have to tell people to stick with that one. Okay, so first thing I do is what? Draw my triangle. Well, yeah, just depending on the information I have. So that's why I draw my triangle. Okay, so I have ABC, and they gave me side A is 11, side B is 14, and angle B is 34 degrees. So, do I have enough information to do law signs? No. So I have to use law of what? Cosines. And I have the two sides and the included angle, don't I?
Why isn't that yeah, shouldn't that be compromised?
What B? It is.
B and the
Oh, yes. Oh, and I forgot my B. Thank you very much. That should be capitalized. Good job, guys. Because sine, we have to have like the complete ratio, and I don't have it. Like, I don't have a side, I don't have a complete ratio. Okay, so I don't care what it is here. I'm looking for side what? B. That's like really my only option, right? Or I could look for an angle. Do you want an angle or side first? Side? Okay, so side B. So B squared equals 14 squared plus 11 squared. Does it matter if I put 14 or 11 first? No. Minus 2, 14 times 11, and it's what law? So I'm going to put the cosine of 34. Now I obviously don't want b squared, do I? Nope, so I take the what? Square root of all of those. And a square root is basically plus or minus, but I'm not going to have a negative length, am I? No, so I just need the plus. So then I put that in my calculator all at one time. I took my calculator home last night. I'm digging for it, guys. Okay. So then, square root of 14 squared plus 11 squared minus 2 times 14 times 11, so that's 154, cosine of 34. If I don't know that stuff, can I put it all in like exactly how it's written? Yeah. Well, hopefully we get the same answer. I get approximately 7.9. What about you guys? Okay. Approximately 70.9. Okay. So now what do I need to find? Angle A or C. So let's start with angle A. So remember, if I start with law cosines, I have to stick with it, correct? So let's go back up here and look at these a second. What? Okay, so if I need A, yes? So I need to rearrange this thing, don't I? So how would I move these things over? How would I move B? Subtract them. So I have A squared equals B squared plus C squared minus 2BC cosine of A, right? So I would subtract B squared. So I had A squared minus B squared minus C squared equals negative 2BC cosine of A. Because I need an angle. I need to solve this for the angle. And so I'm just taking the formula I have and moving it around. Well, this is multiplication over here, right? Oh, yep. I'm sorry, I got it zoomed in. I forgot. There. So this is multiplication on this right-hand side, isn't it?
Yes, you divide.
So I divide by this negative 2BC, don't I? So divide by negative 2BC.
The B and C.
No, they do not. Why?
Why?
Because it's a quantity of minus. Okay, so I have A squared minus B squared minus C squared over negative 2BC. Yes?
Are they all gonna look like that for cosine of?
Well, then we'll look at our relationship, okay? So if this was a B here, what would change over here? The B's would become A's, and the A would become B. So when I do this, when I set this up, this angle, yes,
Can we
So-
write them all out?
if you'd like, but just a second. Okay, but this doesn't give me the angle. What do I have to take of all this to get the angle? The inverse. Good job, Sadie. Remembered something from this morning. The inverse of A squared minus b squared minus c squared over negative 2bc.
So you can use that on all of them now to find.
Yeah, you can use it on all of them because the angle I want, the side only shows up where? The very first one, right?
Yeah.
So if I wanted angle B, this A would be a what? B, and these B's would be what? A's.
Okay.
If I wanted angle C, this would be a C, and these C's would be what? A. So there's not three formulas, is there? No, it's, yeah, when you're looking for an angle, it is always inverse because what we had was this, correct? And I don't want the cosine of A, I want A. So inverse functions, their job, the only job of an inverse function is to interchange the range and domain to allow me to solve for it. That's the only job of an inverse function. Okay, so this right here, and you can write this down, or you can just, could I just move, if I just remember the law of cosines, can I move it around to get this? Yeah, I'm just solving this equation for a different variable, aren't I? Okay, so angle A is going to equal inverse cosine. Okay, so angle A, so I need side A. What's side A? 11 squared minus the other side squared, 7.9, minus the other side squared, over negative 2 times the other two sides. Okay, do you see something going on here? It's important to write this out because if I see this number here, anywhere over in here, did I fill it in wrong? Yes. Now I am going to tell you right now, in most textbooks, they don't leave this negative here. Okay? They take this negative and distribute it through the numerator. So it would be b squared plus c squared minus a squared. But then your brain goes, well, that's a completely new formula. Is it a completely new formula? No. I leave it like this so I can remember how I got it. I don't need to remember this inverse formula, do I? All I need to remember is my algebra skills and the basic law of cosines. That's it. So now I put this in my calculator all at one time. So how I do that is inverse cosine, right above cosine, right? I need this parentheses for the inverse. I need another parenthesis because that numerator is a quantity, so it has to be in parentheses. So 11 squared minus 7.9 squared, I don't know 79 squared, sorry, minus 14 squared. End my parenthesis on my numerator. But I still have this one here that's open. It needs to stay open. Divided by parentheses again. If you do not put the numerator and denominator in parentheses, you are not going to get the right answer. Got me? So negative 2 times 7.9. Oh, that's the 5. Thank you. And you all know that the negative button is right there, correct?
Mm-hmm.
Okay. Because if you use a minus button, it's going to tell you syntax error, right? Times 11. Oh, 14. End the parentheses for the denominator, and then end the parentheses for everything.
I did it. I got it. The first time I did it, I got an error. I really did what you did. Oh, wait, I guess I did carrot too.
Well, that doesn't matter.
I did carrot 11.
It has to be in your parentheses.
It was.
So try it again. Okay. Inverse cosine. It starts with a parenthesis. Then you put a parenthesis for your numerator. So you have 11 squared. Guys, you don't have to use the caret button for squared. It's right there. X squared. Okay. Minus 7.9 squared minus 14 squared, and one parenthesis, not both, divided by, start a new parenthesis, negative 2 times 7.9 times 14. End the second parenthesis and end the first parenthesis. See how it went bigger on mine? Yours it won't, but on mine it will.
Oh, I got it.
So you forgot a parenthesis somewhere.
Oh, girl, I have all my.
Okay. So approximately 51 point what? 6. Now, I'm going to make you use law of cosines again to find angle B, just so we can practice it. Angle C, sorry. So angle C is going to be inverse cosine again because we're looking for an angle, yes? Okay. So if we're doing angle C, we need that side, which is what? 14. So 14 squared minus the other side, 7.9 squared minus the other side, 11 squared. Does it matter the 7.9 or the 11? Which order? Nope. But does it matter the 14's first? Yes. Divided by negative 2 times the two other sides, right? And 11. So if you get your numerator right, you just bring down the second half, right? Now, I'm going to tell you right now, when I do this, I write these two out before I even go to my calculator. I write them out, and then I do everything in my calculator. Calculator slows me down. Okay, so you guys put in the calculator, I'm going to put it in the calculator, and we better get the same thing, right? So let's see if you can do it. I get approximately 94.2. How about you guys? Okay, so we need to, there's a problem here. What do you think the problem is? Oh, yes, I did forget my degree. What do you think my problem is?
Those don't add up.
Those don't add up because I get 34 plus 51.6 plus 49. Yeah, that. I'm missing 2.2. 2/10, right? So when you know why I'm missing 2/10? Our rounding. So does anyone have? I'm gonna put this back up on my screen real quick. Okay, right there. What do you think would happen if I made this 8 and 5? Do you think I'd get better? You think so? Okay, so if I come back up here and I punch this in and I go 8, 5, and make this an 8, 5. So that would be 94.4, right? Okay, but if I went and did it for this one, I better do it for the other one too, right? So let's see if I can find it here. What I'm trying to tell you is we probably should have given ourselves not to the nearest tenth, but to the nearest what? 100th. It says 100th, doesn't it? Yeah. And that's why I'm trying to show you. We need, when we're using something that we rounded, do we need to use more decimal places? Yes. Okay, so 8, 5, oops, 5, insert, and 8, 5, and so I get 51.6. Oh, it is still 6. So now do I have 180? Yes. And I knew there was a problem because I had a 0.6 and a 0.2. Was there going to be a problem there? Yeah. So when you're done with this, should you always check your angles and make sure you have, yes. When you are using law of cosines, we are going to have to use it to find more. Please give yourself to the nearest hundredth. Got it? Okay, well, the older calculators, I don't know if yours does it. Mine allows me to go up and do, like, just pick something and grab it like that. But if you, all of yours, you can hit second enter, and I've showed you how to do that before. I hit second enter until I found the equation I wanted. See that? It's going through my last equations. I'm not sure how many, mine will do more than yours. I think yours does 10. I love it when people second enter. Just no, if you keep doing it, it doesn't change it.
Mine kept changing it. Mine does. Oh, yeah, mine
Yeah, if you hit second enter, it should keep. I think it goes up to 10. People go, I want to see what they're doing, and they're like, oh, I just erased it, so you can't. No, I can bring back up what you've been doing. So that helps you, so you can just do it. Okay. So on the newer calculators, you can just scroll up to where, like, I can scroll up for a long way and grab it. Huh. You can reset them. Right here it says memory. You hit second memory, and then it says reset and all RAM, and you hit 2, and it clears all your lists and everything. So now all my lists that were there, I don't have. When I was in calculus, we would do lists all the time, and when you want to clear a list, you're supposed to hit clear. Well, I wanted to delete numbers in my brain. Like if I put a bunch of stuff in this list and I want to clear it, you go up to there and you hit clear and enter and it clears it. Well, my brain was like, I want to delete the numbers. So guess what I was doing? Delete. Watch what happens when I hit delete. Where'd L1 go? It's gone. I think my instructor had to reset my calculator about 1,000,000 times. He was about ready to kill me. So if you ever do anything that you're like, I don't even know what I did, just reset your calculator. It's fine. What did I go to? Just second memory, second plus. Oh, the stat. Edit, and you can put data in there. So when you guys take statistics, this will be your best friend. Now, I am going to tell you right now, those taking calculus next year, I would suggest that over the summer, right before school, you watch for sales and you buy your own calculator. Those going to college will need to have their own calculator as well because they're going to require you to have, no. Okay, but I'm saying watch for them on sale because you can usually get them about $98 right around that. Right now, this one I think is $130, $140. So watch for right around August in there. What? Well, you recharge it, and when you graph, it has different colors, and it's a lot easier to see if you're going to be using it for stats and stuff like that, especially. So you could hand yours down to Clark and say, I need a new one. Okay, so we need to find the area. So we're going to go back to what we were given. Which area formula do we get to use? We can use the normal one. So area equals 1/2 what? Nope. 1/2 14 times 11 times sine of 34. I didn't use anything I found. Now, if I have to, I do. But at most, you should only use how many things that you found? 1.
I thought we couldn't go back to sine.
No, this isn't law of sines. This is area. Okay, so half is 7, so it'd be 77 sine of 34, right? Okay, so 77 sine of 34. So approximately 40.7 units squared. You put 77 sine of 34. Yeah. And got 43?
Yeah, I got like 43. Oh, I got 43.
Oh, yes, when I reset it, it went to radians. So whoever got the same as me, you were in the wrong mode.
Why?
When you reset the calculators, guys, they go back to radians.
What's the answer?
So is all the answers wrong?
43.1. No, because I reset it after. Yep, approximately, because you're rounding, right? 43.1. And guys, I expect you to put things in all at one time. Don't do chunks, because if you do chunks, you're not going to get what I've got. And I'll put RE on there for rounding error and take a half a point off. You've got a nice calculator that will let you put tons of junk in at one time. Use it. Okay? We don't have to do pieces anymore.
What if we like to do pieces?
They're not accurate. Change.
What? I don't
No.
like it. Hold on,
No.
wait a minute. Listen, because, you take 14 divided by 2, that's 7. Then I wrote down 7 times 11, sine 34.
Okay, but you should be able to. Okay, but
But
you,
no, I want to see it. I wanna see
Okay.
it.
that's
So,
silly.
like, if I miss something, like, I can always go back and see
But
it.
if you put it in your calculator like this, they should be exactly the same.
I can't trust technology.
It's gonna come eat your brain. Okay, first thing, what do I do? Draw my triangle. Yep, there's no angles. Okay, so I've got what, 12? And I changed up my triangle because I get stuck in a rut, and then I do mistakes because I'm stuck in a rut when their picture's different, so I try to switch it up on me. Okay, I don't have any angles, so do I have any hope of lost signs?
No.
Nope. So I'm looking for 3 angles, so I'm going to be doing inverse every time, yes? Except for the last time. I'll let you use, if you do it twice, I'll let you subtract on the last time. Fair? Okay, so should we just go alphabetically? Okay, so angle A is going to be inverse cosine, right? Okay, of that side, 12 squared minus the other side, 27, 20, it doesn't matter, right? Minus the other side, 20, divided by -2, always -2, right? That was in the formula. 27 times 27 times 20. Okay, we're not going to use our calculator yet, but I am going to put a parenthesis. So we're just going to do it all at one time. So we're going to do angle B now. So do angle B, fill it in.
I got it.
Well, do you guys want to do angle C with log cosines, or do we want to subtract?
Subtract.
We can do it both ways. Okay, so C. Okay, I just like to do the formula. My brain's on the formula. I just fill it in my 3 times, and then I pick up my calculator and go to town. Okay, so we all better get the same answers, right? It's very not helpful there, CJ. That's very unsupported.
Why are you making mad today?
Aren't you doing it, CJ?
How do you just go back to that equation?
Second inner.
Second, I don't have that.
Yes, you do.
It's not popping up. This girl got live. Yelling at me. I think you better use to the 100.
You think I better use to the 100?
Well, okay.
Would you get 14.1?
Oh, yeah.
Okay. I subtracted it.
Right. Okay, so when I'm done, I need to do what?
Add them up.
Because if you're 180.1, are you wrong?
Yes.
Yes. If you're 179.9, are you wrong?
Yes.
And now, Maddie said, I think you should go to the 100th. If these don't add up, should I go back and go to the 100th on them? Yes, and look what happened. If I do all three, all three could be on my screen at one time, can't they? So if I need to go back and go to the 100th, I can without redoing the problem. Okay? Yeah, you could if you went to the 100th, but you don't have to go to the 100th. Okay, so we got a triangle solved. I need to do the what? Area. So which one do I have to use on this one? The side. So I need to find the what first? The S. What's S? 1/2 the perimeter, right? So it's the semi-perimeter. I get 29.5. Okay. Okay, did you guys get 29.5 also? Okay. So area equals what now? Yep. 29.5. Like the difference, right? And I can do those differences mostly pretty good. What, 17.5, 9.5, and 2.5? It's the semi-perimeter minus each side. So 29.5 minus 12. 29.5 minus 20. I didn't have to carry, so I could do those in my head. But can I put it all in my calculator if I want to? Yep.
I'm going to.
Okay, you do it. I just like to use that mental math when I can, so I keep it. Because if we don't use it, we lose it. Mathematicians never get Alzheimer's, but they always go crazy. Okay. I got approximately 110.7. How about you guys?
I have a question.
Yes.
So I got that same answer, but I used one of the angles we found in
Right. Nope. Because my rule is,
I got the same answer.
I didn't say you wouldn't get the same answer. Okay, but what's the rule? Use what you're given unless you absolutely have to. The reason for that is if I didn't tell you that, Maddie, you would go use the other one every single time, right? And the other thing is, what if I screwed up on one of those angles? Would my area be wrong? Yes. So anything you're finding, you use what you are given unless you absolutely have to.
What I do wrong?
Okay.
Everything.
Yeah, everything.
You can show my calculator because I'm not the only
Oh,
one who
okay.
did it wrong.
Okay.
9.
Can you see it?
Yeah.
Okay. So let's see what she did wrong. So you got square. Oh, I see what you did right here. When you put this square root in here, it puts a parenthesis, yes? What'd she do? No, but she didn't add another one. She ended the parentheses, so it's only taking the square root of this. So I'm going to hit second enter. So it comes all back up. I'm going to go, you can change that by go second. So then when I come up here, I'm going to delete this parenthesis because first of all, you don't need it. You do not need this parenthesis. If I have 29.5 parenthesis, that means multiply, yes? Okay, so then I have parentheses around here. I have a parenthesis around the second one. I have parenthesis around the third one. And then I need to end this very first one. So you should have open. So look, I've got 1, 2, 3, 4 open, yes? So should I have, how many closed should I have? 4. So I have 1, 2, 3, 4. And look at that.
Nice.
Okay, so that is law of cosines. So today your assignment, I think you still only have like 5 problems. I don't care what the instructions say, you're solving and finding the what? Area. But you do need to go your side lengths to the nearest hundredth. Got it?
Wait, I have one more question.
Yes.
Why do we have to use the half and all that to do the area?
Because they gave me 3 sides, so I have to use what I'm given.
Okay.
And so I need to use the side area formula.
Oh, okay.
Okay, I will tell you guys that I will give you, listen please, I will give you the law of cosines, but you still need to work with trying to remember it, correct? Because it makes it easier to work with. I will also give you the side area, but I will not give you the 1/2 side included angle, because that one should be stuck already, yes? Okay, let me,
Half side included in
okay, I will not, okay, I need everyone to quit talking. I will not give you this area. I will give you this area. I'm not going to tell you what, I'm going to give you this right here. So do I have to know how to get S? Yes, I'm not going to give you this part. I will give you the law of cosines, only this one. So do you have to be able to adapt it all? Yes. I will not give you the law of sines. The reason for that is on the ACT, they do not give you the law of sines, but they give you problems that expect you to use the law of sines, okay? But anything with the law of cosines, it says which formula would be able to use to solve this triangle, and they set up the law of cosines formula for you. Does that make sense what I'm trying to say? The expectation is you know the law of sines, and you know 1/2 side included angle. Got it?